All right, so we've done confidence intervals and we've done test of significance. So what we want to do is we want to talk about the one scenario that we can combine them. So this is doing a test of significance from a confidence interval. It's on page 710 to 713 of your text if you want a couple more examples and a little bit more in-depth explanation. So basically what's going to happen is this would occur after somebody did a confidence interval. So maybe you did a confidence interval, or maybe the book just magically did a confidence interval, or on a test I magically did a confidence interval, and then you would have to do this extra step 5, which is to do a test. Basically you're going to reject or fail to reject, so you're rewriting your step 4 of a test based on the confidence interval that you have. So I'm going to do one that has no context to it, and then we can talk about one that has a context to it. Somebody magically did a confidence interval for us. So somebody somewhere did a steps 1 through step 4. And without context, what they came up with was a 90% confidence interval is 12 to 15 units, whatever that happens to be. And so if we were going to draw a picture of this confidence interval, what would happen is that we would have 90% in the middle, and we would have 5% in either tail because there's 10% that's left over. Our confidence interval, 90% confidence interval, is going to go from a lower bound of 12 to an upper bound of 15. And so we have this confidence interval. This is part A. Maybe we did it in part A. And part B says, is there significant evidence that whatever is not 13? So is there significant evidence that blank is not 13 using the confidence interval? So I know that it's kind of a test, but I have to use the confidence interval that I did in part A. I also know that the alternate is a not equal to, because in the question it said, is there evidence that blank is not 13? So that's the first key, is that if I'm going to do a test from a confidence interval, I have to have a not equal to as my alternate hypothesis. The second thing is my alpha needs to be the complement to the confidence interval. So if I have a 90%, I need a 10%. If I have a 99% confidence interval, my alpha has to be 1%. So I have to have those be complements to each other. Okay, so the concept behind this is that if I did have a null hypothesis that was 13, well, 13 would be in this interval. It would be someplace over here, let's say. And if I was going to do a test based on a 13, and I looked at the p-value, this p-value right here is obviously more than 5%. Remember, my alternate is a double-sided though. So whatever I have on one side, I also have that same thing on the other side. So my p-value together is going to be more than 10% because both of those sides are greater than 5%. So if my p-value is greater than 10%, that means that I'm going to fail to reject because my p-value is greater than my alpha level. Another way to say it is I can say that this 13 is in this interval right here. So the 13 is a very reasonable estimate because it's in the confidence interval itself. Okay, let's say on the other hand, I had something that was a 10. So same question, same interval, I just have a 10 instead. So if I draw this out, I'm just going to redraw. Remember, it's the same interval. These are horrible normal distributions, but I'm going to go with them. 5% on either side. This is a 12 to 15. If I were going to look at this one, I have a 10 here. A 10 is going to fall over here, which means that the p-value will be less than 5%. Since it's a not equal to, it's a double-sided, so I have that on both sides. I have two p-values that are less than 5%. I add them together. I'm obviously going to get something that's less than 10%, which means that I would reject the null hypothesis because my p-value is less than my alpha level. Another way to put this is that the 10 is not in this interval. Therefore, it's an unreasonable estimate for the population. Okay, so let's do a context problem. Context problem. And this is problem 40 from your text. I only put the last part of it. If you want to read about how they measure sugar in roaches, go for it. But I took out the gritty stuff. So we have a 95% confidence interval that the mean amount of sugar in the hindguts of a roach is 1.9 to 6.5. Is there evidence that the mean amount of sugar in the hindguts is not equal to 7 milligrams? And I'm just going to edit this question right here because it would say somewhere, would say based on the confidence interval, is there evidence that the mean amount of sugar in the hindguts is not equal to 7 milligrams. So the first thing that I'm going to do is I am going to write out my null and my alternate. My null is 7 milligrams, and my alternate, it says it right here, is there evidence that it's not 7 milligrams? I would also write out sentences for both of these. I'm not sure it's worth our time to write a sentence in this vodcast, but basically the null hypothesis would say the mean amount of sugar in the hindguts of the roach is equal to 7 milligrams, and the alternate would say the mean amount of sugar in the hindguts of the roach is not equal to 7 milligrams. Okay, so now I'm going to make a decision. So at alpha, remember, alpha has to be a complement to the confidence interval. So in this case, it would be, hopefully everyone said 5%. At alpha of 5%, we will reject that the mean amount of sugar in the hindguts of a roach is 7 milligrams in favor of the mean amount not being 7 milligrams, because 7 is not in the 95% confidence interval. So it's not in the interval, which makes it an unreasonable estimate. So somebody did a step 1 through 4 for me, or maybe I did it in part A. So right here, somebody said, hey, construct a 95% confidence interval. I did it. I got 1.9 to 6.5. And then part B says, hey, based on the interval you did, is there evidence? And so remember, there has to be two things if I want to do a test based on a confidence interval. I need for my alternate to be a not equal to, and I need for my alpha to complement the confidence interval. So I did my null and alternate in math and in sentences. Then I started out with, here's my alpha. I said I'm going to reject in favor of. Notice I put everything in context. I didn't even say null and alternate in my explanation. That's what you should get to with all of your tests. And then I gave a reason why. And I said it's because 7's not in the 95% confidence interval, therefore it's unrealistic. So remember, graphically, if I was going to do this, which I don't have to, but this is just the concept behind it. Graphically, in this case, what's happening is that's horrible. Oh, that's horrible. Okay, I have a normal distribution, and this one is a 95% confidence. So that means there's 2.5 in each tail. And my interval is 1.9 to 6.5. The null hypothesis that they're asking me about is 7. That would produce a p-value that's less than 2.5. It's two-sided, so I have the same p-value on the other side. So if I take something that's less than 2.5 and double it, it's going to be less than 5%. So it'll be less than the alpha, and that's the whole concept behind it. On your assignment sheet, I do think that I made a mistake because I just copied what last week's was and I forgot to update it. Your homework for tonight, I already told you, but just to remind you, is 11.31 and 11.33. Actually, that's your homework for the class period. The class period is the vodcast and those 2 problems. And then your homework is actually quiz 3 and quiz 4. Yay!